Yeah, great. Thank you.
Okay. Well, hello, everybody, and welcome. And thank you so much. I'm sure you started your day very early, and I appreciate that you're here with me this afternoon. My name's Ileana Alanis, and I'm a professor at the University of Texas in San Antonio. And so that's the San Antonio city skyline that you see behind me. That's our downtown area. And of course, I've done a series of these workshops with ECPL. So perhaps some of you have been here before. So if you have, it's good to see you again. And if you haven't, welcome. And we will have two other workshops, one in April, one in May. So be on the lookout for those as well. Today, we're going to talk about math and science. I basically have three objectives. Talk a little bit about why it's important that we introduce math and science concepts in the early years. Moving away from the notion that, oh, the children are too young to understand math and science concepts, looking at some strategies that other teachers have been using that I want to share with you, and then talking a little bit about, what would be an appropriate math concept or science concept, what's developmentally appropriate for young children. And as we go through the session, I have a couple of things to ask of you. Of course, one is just to be present, which I realize how hard that is on Zoom because it's so easy to do something else, to get distracted. We ask that you take at least one risk today. So if I say, okay, anybody can unmute themselves and answer this question or contribute, a comment, then, take a risk. We will have some chat box discussions and then a couple of breakout rooms where, again, just like Susie mentioned, you'll have to click to move over to that room and then share your thoughts and ideas with a smaller group. And then, of course, it's 90 minutes, so take care of your needs when you need to get up and get some water or, go to the restroom or let your dog in or out. That's always my thing. I have to let my dogs in or out because it's a constant with them. So I have them downstairs for now. And then I had found this and I thought, oh, this is funny. Because for those of you that are in Zoom meeting with video, right, we get all ready and all, presentable. My mother used to say, oh, I don't want to scare anybody, so I better put my makeup on. So, and then of course we know that when we have the audio only, it doesn't matter what I look like or what I'm wearing. So if you can, we appreciate you having your video on. I know it's for some people, it's not, it's just wherever you're at right now, it's not appropriate, or it doesn't work out that way. But we would just definitely love for you to have your video on, because what ends up happening when I feel like I'm talking to nobody, and then I'm like, is anybody out there? So seeing faces, like I see Patricia who's smiling and nodding, is wonderful. That's a good audience member. So, okay, since we're talking about math, I have a little math question here for you. You can put it in the chat, and it says there are 4 oranges and you take 3. How many do you have? You can just put that number in the chat. So I'm going to ask you to really read that question. I think Mary picked up on her. Yeah. Yes. So it says there are 4 oranges and you take 3. So how many do you have? Now you have 3. Right. I know. We want to say 1 because 4 take away 3, but it's thinking about, oh, and the image of the 5 was a trick. Well, really, this is 1 cut in half. So there's 4 there. I know. When I first looked at it too, I thought the same thing. Yeah. So the answer was 3. Okay, let's try. You have another opportunity. This is more like a riddle. It says 2 math books complain to each other. What do they tell each other? What might they tell to 2 math books? What might they say to each other? I'm full of problems. What else could they say? Can you solve my problems? Right, right. Sorry, I didn't mean to do that. Yep, you got problems. That would basically be, or I got some problems. Help me with my problems. Right. Okay, good. So that was just to kind of get us into the, thinking about math for this part. Oh, I love it. That's the sum of it. And then shall we add or multiply together? I'm not a therapist, solve your own problems. Okay, Patricia, I like that one for sure. So as we go today, we're going to really just take a few minutes to talk about the significance of learning math and science in the early years. And I have to say, I did teach first grade and second grade. And of course, first and second grade math I could do, no problem. But I will tell you that I don't like math. I'm not a math person, which is, of course, my husband, has a hard time. Like, what do you mean you don't know how much money you have in the account? I'm like, I'm not a math person. I don't know how much money we have. So, but as I read more and talked to different people and learned from teachers, I have figured out that really math and science in the early years isn't as complicated as some of us want to make it out to be. And so when we talk about math, we know that math is in preschool is really significant to later math achievement because it's a cumulative topic of study. So as they develop those foundations, they continue to build on them. And then we know, of course, that young children can learn essential math and science concepts. They're more than capable, even at a very young age to grasp some of these concepts. And then, of course, it doesn't only predict later math achievement, but just later academic achievement. So this concept of math at an early age, and really thinking about math, the language that we're using with children and how we're focusing on concepts is definitely significant for them. And then the same thing will go for science, right? If you think about it, children are natural scientists. They are always making observations and always asking questions. And if you really think about it, they're always collecting data. And what's interesting, of course, we know is that infants are born with, billions of brain cells, right? These neurons that are just ripe for them to start making sense of the world. So they're naturally carrying out simple experiments and investigations. I remember when my own son would play with the water bowl and the dog bowls, right? He would play with the water and the dog bowls. Well, he was making his own simple experiments, observations, and collecting his own data to make sense of his world. And then, there's this big concept of STEAM. At first it was STEM, right? Science, technology, engineering, and math. And then it became STEAM because they added the arts to that. And so and now we're in the university and education, we're talking a lot about engineering education. So training our teachers to think about engineering concepts in a way that's available to young children, particularly in elementary and secondary schools. So engineering, that they refer to it as habits of mind. So this notion of paying attention, collaborating, being creative, having persistence, and being able to communicate your observations, your thoughts, your predictions, your findings. So the thing is, and this is where I think teachers, because I work with pre-service teachers, and a lot of times they, just like I said, I'm not a math person, I don't do math. But the idea here is that you don't have to be the expert in math, science, technology, engineering, or art, because all of this will grow together through experiential learning. And you can, when we're thinking about working or helping children develop these concepts, some things that we've asked teachers to think about is, don't always answer questions, but do more of a, why do you think that is? Or why might that be? Because they'll form concepts and ideas as they engage in this curiosity and in these questions. And then really getting children to think about these STEAM habits, right? These STEAM habits, which are the ones we showed earlier, like persistence, attention, collaborating, creativity, communication. And then thinking about when I'm developing STEAM activities in my classroom space, how am I going to encourage families' engagement, right? How am I going to tap into their cultural wealth, the resources that they have at home and what they can bring to the classroom space. So a lot of incorporating STEAM into early learning, we know, is going to be very hands-on. And a lot of it will also be through, hands-on activities, but also through literature. So the other thing is to remember that these concepts of STEAM, science, technology, engineering, arts, and math, really are interdisciplinary with literacy. So that the more we engage children in these early concepts related to science, math, technology, engineering, then you are actually helping them develop language and literacy. And then, of course, the idea is for you to think about, how am I going to infuse all of these different activities, practices, and concepts into the curriculum that I'm currently using, right? So we're going to talk a little bit about that today. So if you look at this picture, what do you notice? And I'll just leave it open. You can put it in the chat or you can unmute, but what do you notice about that? What are the kids doing in that picture? Oh, let's see, I'm going to the chat. Planting something. Yep, there could be investigating dirt, measuring the dirt, gardening. Yeah, exploring dirt. What's kind of funny is that the teacher had them all, they were going to be planting something. And so first she wanted them to kind of explore the dirt, just like you're saying. And then they were going to scoop some of that dirt, which they already did, into the little cup so that they could plant something. But they were definitely observing, they were smelling the dirt, the soil. They were exploring it with their hands, feeling it. And the teacher told the children, you can use the gloves if you'd like, because she was thinking like gardening gloves, or not. And so, of course, some children had the gloves and others didn't. And we recommend, don't give them the gloves because we want them to feel that dirt. We want them to get their hands dirty. But that's something as simple as let's explore the soil, right? Can be a STEAM activity, because then we're going to develop language. So let's talk a little bit about some strategies, but let me first kind of ask you, and you can use the chat or unmute, what are some things you're already doing with your curriculum, in your settings that are helping children develop math and science concepts? So what are some things you're already doing?
Having visuals and actually the actual things that they too can touch and count.
Right, so hands-on, visuals, definitely. Let me go back to the chat. Lots of counting, definitely that one-to-one correspondence, math manipulatives. Yes, because remember, all of these concepts can be abstract. So we're trying to make them more concrete by having the manipulatives, the counting objects, the actual hands-on pieces. And then somebody says, items to explore, magnifying glasses. And I saw somebody said, voting on snack choices. That's awesome. We're going to talk a little bit about creating graphic, we're voting. But yes, voting. Tomorrow they're going to be making sensory bottles. That's great. I have several of those in my garage. And then building focused vocabulary to help with overall understanding, charting, and talking about more or less. Yes. So the idea here is not only are we developing math and science concepts, but we are developing language, right? And of course, literacy concepts with the prediction as a part of a literacy concept. And of course, using games. So the first strategy I'm going to talk about is kind of what we've been saying, is making sure children are using their senses to learn. And what's interesting is that when we've gone into preschool classrooms, teachers, just like you mentioned, are using a lot of these activities, and they're using a lot of manipulatives and objects, but oftentimes the teacher is using it as a model or a demonstration, and the kids aren't necessarily using them. So we want to make sure that we're giving children an opportunity for all of them, right, to tap into their senses. And that includes tactile, hearing, smelling, and tasting when possible. So we know then that young children, we learn through interactive play-based sensory experiences, and we really emphasize this because young minds are thriving when engaged in these fun, interactive experiences, or earlier, like when you said games. So games, group activities, hands-on learning, it makes the process enjoyable for them, and then it really provides these language-rich environments. So exploring their environment, right? Going back to senses, taking them outside. Opportunities for play, we know, is how children learn, and then interactions with others allows them to practice their language skills in a very social context where you can promote the language, and the social development. So you can see where they're just playing, exploring with in the water table there. But having a partner there provides an opportunity for me to hear language being used or use the language through interactions. So we know that all learning begins with perception for young children. So that's why we focus so much on, and we've had other workshops that you may have attended where we have really talked about using senses. And again, not just hearing and seeing, but really the taste, the touch, and the smell is significant as well. So these concrete sensory-based experiences really should be preceding those more abstract experiences. And the younger the child, right, the less we should rely on secondhand experiences. So we should really be planning activities so that sensory engagement occurs early rather than later in the learning sequence. So visuals are good, but before I even get to the visual, I'm going to have the actual object as much as possible. So let's look at, oops, I'm not sure what happened there. If you look at these pictures, let's just take a minute and, this is what sensory experiences look like, but what do you notice? Just anything that you notice. Again, you can put in the chat or you can unmute, but what are you noticing about these children? In all cases, children are what? Engaged, yes. Lots of touching, using their senses, multiple senses, exploring, using hands-on learning with their senses. Because really from birth, children are active learners. They're constantly taking in and organizing information to create meaning through their relationships, their interactions, their environment, and their overall experiences. And so again, we really want them to get their hands dirty as part of this process of learning so that as they're exploring, you are providing them access to concrete objects. And what happens is that the involvement of the senses provides opportunities for this joint attention. When they encounter something that's tangible, right, and can be observed, and nature is a great example, then they become very invested and they're very, like you said, engaged, very interested in the learning process. Nature is it's a natural opportunity for them to become invested and excited about the learning. So you can see how the first picture, she's actually trying to taste, right? They're using that sense of taste. And the leaf is rough on this picture, so she can feel it. Of course, the bubbles, she can smell them. She can feel the water when it falls on her. We see Jessie there with the dirt. And then the preschoolers over here on the bottom left-hand side, they were looking for insects. They were outside looking for insects. So what I wanted us to do was kind of think about how we use our senses to classify. So what I'm going to ask you to do in a minute, I'm going to go ahead and put you in a breakout room, is I just want you, wherever you're seated, pick up something that's close to you, look at it, examine it, think about its characteristics, its properties, its attributes. So for example, if I picked up my coffee cup, then I would think about what are the characteristics, what are the properties, what are the attributes? And in a minute, I'll put you in a group, and I'll probably put you in a group of 4 versus a partner. And you're going to kind of compare the objects that you picked up and identify some similarities and differences. Think about, we'll talk about how you came up with those conclusions, and then we'll talk about the science and math concepts that children might develop. So the first thing for you to do is find something that's close to you that you can actually, pick up and hold, look at it, think about its characteristics, properties, or attributes. And I'll let you do that. And then we're going to move you into a breakout room, 4 of you per breakout room. And you're going to talk about similarities and differences. And then how did you come up with those conclusions? And then when we come back as a group, we'll talk about what science and math concepts children might be developing with just this simple activity using their senses to classify. Okay, so any questions on what we're going to do? Okay, so Susie, I think, let me see.
How many minutes?
Oh, okay.
would you like?
Oh, okay, let's just really like 3 minutes
Okay,
and we'll do group of 4.
okay. I'm gonna open the rooms.
Okay, thank you.
You're welcome.
You can unmute.
Hello, good afternoon. This is Felix.
Hi, Felix.
I'm driving, so I won't turn on the camera because I want to make sure that I get home alive without accident. So I was in a room with just one more person,
Okay.
and she had a Sharpie, and it was, by her description, one of those Sharpies that has a smell to it.
Oh,
Although,
yeah.
honestly, I think all Sharpies have a smell to them, and I really like that smell, even though maybe I shouldn't.
I know.
Yeah, right. It's weird. Anyway, so her item was that Sharpie. My item was the bottle cap from a water bottle. Um, so they would obviously very different in shape, texture. My item, because it was made with a flimsier plastic, I guess, was flexible. Hers wasn't. The shell or the casing of the marker itself, in her case, was smooth. Mine had ridges, so it made it rougher. Mine was translucent. Hers, obviously, being a marker, they usually are. You can't see the contents inside, and hers stains your hands if you don't use it correctly. Mine doesn't. So.
Right, right. So if we think, thank you so much.
You're welcome.
So those of you that were listening, if you think about it, what was some vocabulary that children may have been using or picked up? Or you can even think about in your group of 4, what was some vocabulary? So go ahead, Kathy.
We came up with comparison, evaporation. We had water bottles, cell phones, and the mouse. And we came to our conclusions by analyzing these items through hands-on observations.
Yes, using our senses. That's right.
Mm-hmm.
Because we in our group, we had 2 of us had coffee mugs so we could smell it. And then somebody had a candle so you could smell the candle. So there was that sense of smell. And then, but yeah, so words like translucent that Lamont put in the chat room, flexible, right? Just the compare, similar, different, all of that is vocabulary that as children engage in this very simple activity of, find something in the classroom and then come back together and let's look at it and analyze it. Then that's vocabulary. And then, of course, what are the science and math concepts that are being developed with this?
Yeah.
What would be some, like classifying was one, attributes. What are some other math and science concepts?
Weight,
Weight,
measurement,
yes.
and what we came up with was I had a thermos. So it looks like a circle, but it's really a cylinder.
Cylinder, right.
Other words, the weight of it, empty, and when it's full.
Right, the weight, yeah. In my group, I think I was saying sphere and I meant to be saying cylinder.
Yeah.
Now that you said that, I was like, wait a minute, I said sphere with cylinder, yes. Yeah, so all of that vocabulary, so that's what we're trying to say. Even if something that we think might, doesn't seem to be a very challenging activity, and of course it's not because it's young children, but you are asking them to use their senses to make observations, to make predictions, like which one do you think might be heavier, and to talk about those attributes, those characteristics, and those they're going to use those attributes, of course, to I'm looking to so I can share my screen. Using those attributes to, let's see, to classify. Okay, let me see. Let me look at my chat real quick. Yes, volume, that's right. Texture, softness. Okay. Oh, yes, Patricia.
And I had picked up a tangerine. So this would be really good, especially for like younger kids. It could be a nutrition and math activity using your senses. smelling, tasting, their fine motor, peeling it, counting how many pieces can each child get, compare. Are they all the same? Are they different? Where they grow? And not all the children might get the same pieces. Some may make it a little thicker than the others.
Yeah, and then there's also, counting the seeds. Does yours have seeds? Mine didn't have seeds. Peeling it, what is the skin of the tangerine called, right? Like what's the actual science term that we could use there to augment their vocabulary? I'm going to share this. Thank you. I'm going to share this video. These are 3 and 4-year-olds. And, my work is always a dual language teacher. So these are Spanish English classrooms. So this is a video in Spanish. So I'm going to kind of set up what's happening is that they were talking about their big topic to talk about was water, right? Their big theme. And on this particular occasion, they were talking about that we needed to be careful because water is a natural resource and we don't want to contaminate it. So that was the whole, issues of contamination. So she had, and it's really just water with food coloring, but she had what she said was, she did have actually vegetable oil. So that was real. Then she had something that's really dark that she said is like industrial waste, but it's just food coloring. She had petroleum is another one that she says she has petroleum. And then which is yellow and it's food coloring. And then she has plastic because we also can contaminate the water with plastic. So now let me hope this video works. So what she does first is she says, this is what we're going to do. And as she's doing it, the children are engaging in this activity with her.
Desecho industrial. Espérate, Rosy.
So can everybody hear it? Okay.
Oh, Lincoln, agarra, si tú tienes una horquilla, agarra el desecho industrial. Todavía no. Enséñamelo a la maestra. Ahora sí, vamos a contaminar el agua desafortunadamente. Vamos a contaminar el agua. Ponlo, vamos a el líquido adentro del horno. ¿Eso qué? ¿Eso qué? Aviéntalo al agua. ¿Qué le pasó a el desecho industrial contaminó el agua. ¿Qué le pasó al agua? No, si tú no tienes la horquilla, si tú no tienes la horquilla, agarra el petróleo. No, para eso. Bueno, gracias por dar instrucciones. Ahora todavía no. Ok, ¿tienes el petróleo en la mano? Enséñame el petróleo. Enséñamelo. Que ahora sí. Vamos a contaminar el agua otra vez. Haciéndolo adentro. El líquido allá abajo. ¿Qué le pasó al agua? ¿Qué le pasó?
Okay, so now let's just think about it. I'll just open it. What do you notice about the children? Let's start with children first. So definitely very excited. Curious, yes. I see Nilda. Engaged, having conversations about what's happening, definitely engaged. And smiling, laughing, talking. What do you notice about what the teacher is saying as far as the vocabulary? So yes, they're all participating. She's using big words. We're going to contaminate the water. She says we're going to use industrial waste. We're going to use petroleum, right? She says, unfortunately, right? She continues to repeat it, right? Oh no, we're going to put the liquid in there to contaminate. Unfortunately, we're going to contaminate the water, right? Now, I will say what I find interesting is, the concept here was we need to be careful to not contaminate the water. But of course, the kids got excited about it turned yellow, it turned green, so that's okay, right? Because this wasn't the only time they were going to talk about contaminating water. So throughout the week, they talked about contaminating water, so that eventually, they are adopting that vocabulary. And what's happening as she gives them this new vocabulary is because they are engaged in a sensory-based activity, I can attach that vocabulary word to the object. So if you tell me, this little cup is yellow petroleum or black petroleum, then I look at it and that's the label I'm going to use from now on, because whatever label you give me, that's what I'm going to attach, because we're having a joint attention, right? I'm looking at it, I'm experiencing it. So when you say it, I'll attach it. So the first thing is, when children are engaged using their senses, they are highly motivated, they are paying attention, and they will pick up that that you are using. Let me see if I can go to the next slide here. So the first one is using their senses, but the second is what you hear the teacher doing is that rich descriptive language to label actions, objects, events that are at the center of children's attention, that joint attention. So Lamont is saying, okay, this would be great as a follow-up, but I will tell you that they were doing this all week, and this just happened to be the day that I was there and the day that I captured that video. But they did other things throughout the week to talk about water and contaminating it. But that's why, they're so excited, because this is a Monday. I will say I would go in on Mondays. And so throughout the week, they continue to talk about that. So as the teacher is engaging with these activities, she's also using that language to label. And the idea here is, even when you are working or talking with a 1-year-old, a 2-year-old, when I say to that child, like, where are your shoes? Let's get your shoes. Oh, we got to put your shoes on. They start attaching the word shoes, the label, to the object. So that's the same thing we're doing here, is we're saying, if I'm trying to develop language, in this case, math and science language, then because children it's real to them, they can see it, touch it, smell it. When you attach the label, they will start to use that label. We don't have to dumb it down, right? We don't have to make it like it's an easy word. No, we can use the actual, word, in this case, contaminate, versus getting it dirty. Now, I will say later when I was talking with children, they would say, oh, the water is yucky. So they understood contaminate is dirty. It's yucky. But the word he wanted to use at that time was yucky, right? So using that rich descriptive language to name objects, actions, and events in these patterns of interaction where children are highly involved, highly engaged, highly motivated. So the suggestion is using that rich, precise, descriptive, in this case, it could be academic language, because that's the language that children will adopt. Regardless of what their home language is, the more you're using the language, the more that's the language they're going to use. The more opportunities they have to hear it and use it. In this particular video, they're talking about, this is same campus, different teacher. They're talking about electricity and objects that either have electricity, produce electricity, or do not. And she's going to talk about, sometimes it's electricity because you have to plug it in for the electricity. Other times it's because they use a battery. So they're sorting, does it produce electricity? Does it need electricity or not? And they each have little objects, and we'll see what she says here.
Real, la conectamos a la, ¿viste?
The electricity. Lo voy a probar. ¿Y este es un qué? Ajá. ¿Qué pasó? ¿Qué está haciendo la electricidad? La electricidad que hizo, prendió el phone, el phone, the electricidad. Ok, otro par bilingüe, ¿listos? El par bilingüe de soy. Dile, ¿ustedes qué tienen? Los maestros. Y nosotros tenemos. Mande, ¿qué es esto? ¿Qué es? Ayúdenlo. Power dealing en español es un taladro. Y adro, el taladro. No, los papás, unos taladros funcionan que tienen un cable y los conectas a la electricidad. Y los papás hacen sus hoyos con esto. Pero unos taladros también tienen batería. Batería. ¿Y tú qué tienes? Amelia, ¿tú qué tienes? Ayúdale a tu padre, ¿tú qué tienes? ¿Ande? ¿Una qué? Y en español, ¿cómo se dice? Cinta. No, espérate. ¿Esta cinta métrica funciona con electricidad? No, vamos a ver, pruébalo. ¿Listos? Esta es una máquina simple. No, funciona con esa pulley, una polea donde le da vuelta. Una polea es un poquito diferente, de una palanca. Y palanca, es una máquina simple. No, lo pongo en el
Okay, they had studied simple machines, which is why the little boy says it's a pulley, and she says, well, it's similar, right? But it is a simple machine. Okay, so what do we notice? We're talking about the strategy of using precise, rich academic language with young children. Anything that stood out for you?
They understood it.
They definitely understood the concept, right? Of does this need electricity? Does it produce electricity? You know, is this something that has electricity? She uses sentence starters. And earlier, like somebody had said earlier, that she uses a lot of repetition, good pacing, right? The kids staying with her, the kids are engaged. This is in the spring. So the kids are already used to this routine. So yeah, it was, you know, really exciting to go into this classroom. And yeah, she uses a lot of repetition and she's doing it in Spanish, but what she does actually in Spanish that's interesting is she focuses on the ending sound. So she has them repeat a lot of the ending sound for that phonemic awareness as she's engaging in these activities. And so this teacher, you know, on her own, before we even did any professional development with her, she was already doing a lot of this. I just use the actual vocabulary and I teach children at a very high level and they respond. So their vocabulary in this classroom space is phenomenal because she's constantly asking. And the other thing I don't know if you notice is when she doesn't hear them, she really reinforces like, I didn't hear you. Everybody needs to say it. Everybody needs to talk because you have to produce the language, right? To develop that language. So again, it's just asking teachers to use hands-on learning, sensory engagement to label actions, events, or objects. So if we look at this picture, what's at the center of this child's attention? What could I name and provide a label for? Yes. So I'm sorry, what was it?
Legs, antenna, beetle.
Okay. Yes. So at the center of his attention is a beetle. Another word we could have used is insect, right? And then, like Lamont says in the chat, all children are going to benefit from this exposure and use of high level vocabulary. So when you say, let's talk about the characteristics of insects, Patricia, we say, did you notice its antenna? And because he can see the antenna, he might even be able to feel them, right? And I say, how many antenna do you see? Let's count them with me. 1, 2 antenna. Jessie, do you have antenna? So now I've attached a word there. I say, how many legs does it have? Let's count the legs. Think about our math, right? Count them with me. Oh, I see that these legs have 3 segments. 3 segments. I wonder why. So all of that is the opportunity the teacher has to develop. And of course, we're going to develop head, thorax, abdomen, and we're going to develop that it's a beetle. The color, it's coal colored, very good, instead of just black. Yep. How many legs? It has a hard shell. Yes. So it's all of that vocabulary that's connected to math and science. So, you know, if we just look at a leaf, the language that we're using is also, you know, small, pequeño, right? Yep. So here we see, yes, I can say, oh, this is a leaf. It's green. It has veins. But I could also use a lot of the actual science terms to talk about the margin on the leaf, the tip of the leaf, the stem, right? The midrib. And what's amazing is, of course, if I'm using that vocabulary and children have lots of opportunity to describe a leaf and to do that with a partner, they will start to use that vocabulary. So again, we're thinking of math and science, but we're thinking of all that vocabulary that we're developing for children as a foundation, right? So using their observations as that foundation so that they're just describing, just like you did earlier with characteristics, attributes, and using, like earlier you said, using magnifying glasses. The third strategy, I have to keep track of my time, is to ask questions that form habits of mind. So going back to, what does it smell like? What does it sound like? How would you describe it, right? How could we find out? It's doing that, you know, let's investigate. So that curiosity. And can you think of another way that we might be able to see that or ask or to find out? So the idea then is always asking children to be scientists, right? What does it look like? What does it smell like? How could we find out? So what other questions could we ask if they're looking at and investigating leaves? And this was just outside in their playground. What other questions could we ask? We could talk about the color and we could give them the vocabulary of it's shiny or it's dull, right? We could say, because this is, a lot of the leaves aren't green anymore. We could say it's, you know, we could discover other words for brown. Oh, which tree do you think it came from? Which tree? And then think of the shape, like some leaves look like a triangle, right? Oh, is it a young or an old leaf, right? How does it feel? And feeling the edge, let's feel the edge, the margin, the tip. Oh, it's crunchy, it's bendy, right? All of that vocabulary is what we're talking about. So the first thing, again, I know we're talking about math and science, and I focus a lot on language because it's a lot of language that we're developing at this age, is to think about, so what are the 3 strategies? What are the 3? So the first one is that we are bound by perception, so we need to use what? When we're working with children, they need to be using their, Patricia, is a leaf edible? Yes. So the first strategy was children need to be using their, you can unmute and just shout it out. Their senses, yes. The second strategy was teachers need to be doing what? Teachers need to be
Using correct vocabulary,
yes, using the
Descriptive. Academic vocabulary.
Yep, using rich descriptive language, making observations out loud. I noticed or I observed. Did you notice that? Right? Thinking aloud. Yes. I wonder why that leaf is so crunchy. Why does it make that sound? Asking questions. And the third one, of course, was this notion of forming those habits of mind with the questions, right? Asking questions. questions that form habits of mind. So those are the first three things to be thinking about, whether I'm teaching in the language arts, math, science, just throughout my day. That is what we want to be thinking about. And for the teacher, all of this is relying on you, right? Setting the stage for them to engage in senses, using that rich descriptive language, and then to label actions, events, objects, and then asking questions that form habits of mind. So when we think about math in particular, we know that it's important that we communicate math in our everyday practices, these math ideas in our everyday practices. So if you think about what children are doing throughout the day that would connect to math is, of course, they're jumping, and we could talk about how high did you jump? How far did you jump? We could be throwing rocks, let's measure how far we threw the rocks. Did you throw it far? Did you throw it close? Using that language. Finding objects, like we said earlier, just let's find objects, let's describe objects, let's count objects. In some Head Start classrooms, children set the table, right? So there's opportunities for math. Of course, sharing food, right? You get one, I get one. There's that correspondence. And showing, puddles of water, right? What happens when we step in a puddle of water? Is there a sound? Is there, action that's happening? Of course, when they engage in building blocks and cooking and then counting. So every day, even if I'm not at math time, right? That's the beauty of young early childhood, is that everything is interdisciplinary, and we're engaging in our math-related ideas in our everyday practices. So here's what we know about math and young children is that it'll typically, their math knowledge will follow this sequence. I'm going to let you look at that. So talking about larger and smaller, one-to-one, but then also counting on, making number comparisons. That the number, when I count on, the number after equals one more. And then, of course, we can talk about comparing, right? Like how many children walk, how many children take the bus, how many children are picked up in the car, comparing. So young children really begin to think about counting, adding and taking away, measurement. And I have this little quote here that says too much. So when my son was little, if you would ask for something to drink, I would say, okay, I'm going to give you some, but not too much, right? I'm going to give you some, but not too much. Well, he was really young. And one day he asked for some milk and he said, but mommy, I want too much. So he understood, oh, not too much means a little, but if I say I want too much, it's going to be more, right? Or a lot. So they are picking up on these concepts, of course. And so that's why the language that we use is so significant. So if you think about what I said earlier with the strategies, it's that to support these math concepts, I have to provide something that's very concrete. And then earlier, somebody said visuals. Yep, I'm going to also provide and move into pictorial representations. And that's going to facilitate these abstract concepts and this abstract representation. Lamont says too much goes with just right and too little as well. Yes. So the concrete representations is just like you said earlier with manipulatives, counters, concrete objects. And then as children gain more self-confidence, like somebody said, more comfort with concrete representations, then you can begin to use those pictorial representations, sketches, drawings, which prepares them for those very abstract use of symbols like plus, minus, and equal. And then, of course, making sure that as teachers, we are using language, right? The language of math. So it goes back to that more or less, under, inside, bigger, smaller, first, right? So all of that language that we're using as we engage with children throughout the day. So if you think about in our early childhood classrooms, we use a lot of unit blocks, right? So unit blocks, of course, are a phenomenal way for children to develop some early math concepts. And a deeper understanding of space, right? The use of space and the relationships between objects. So things to consider is they are going to be building, so they do need space and a smooth surface. So a low pile carpet works really well. But also thinking about materials that reflect the age of children. So maybe you're not using the unit blocks, but you're using Duplo blocks. And I was in a classroom one time and the kids were struggling with like, teacher, I don't have enough space to build, basically what was happening. So she used the blue tape here to define that this was the building area and they could only build in the designated zone to prevent some of that, arguing of getting kids, to move so I could make my skyscraper. So when we use our unit blocks, things to think about, aside from designating an area, is adding pictures from your community onto the blocks so that children can then develop their own neighborhoods. Adding books, and you can see in the picture here, adding books that relate to building or construction, and then labeling the shelves. In this case, what this teacher did, of course, was the shape, right? She put the shape so that now kids are also having to look at attributes. And even in the cleanup process, they're focused on the shape, the attribute, and sorting, right, as they put away where things go. We would also recommend that you label as much as possible. And we, of course, are in bilingual classrooms, so we label everything in English and in children's home language. And even if you have 3 languages represented, you can have those 3 languages there. But again, matching the blocks to the shape helps them with spatial orientation and, of course, the actual attribute of the shape. So with the unit blocks, you can ask children to count the number of blocks that they use to build a tower, measure the height of the structure, and of course, they could use standard and non-standard tools. They could use masking tape to outline those complex shapes. And then the idea then is to keep reminding yourself to use that math vocabulary, like this double unit is twice as long as the half unit, right? So this block is curved, and this block is straight. So, using that, being very intentional, and that's what this requires, of course, intentionality, to label objects, actions, and events as they're engaged in the process. As we think about math concepts, I'm going to just ask you to think about what are some math concepts that children develop just by using ramps? What do you think there are some math concepts that children would develop?
Height.
Height,
Speed, the way
speed,
something's
up,
coming down.
down. Yep. Let's start on the top. Let's let it roll down.
Mhm.
Gravity, weight, velocity, faster, slower, distance, heavy. Let's test it out. If the object is heavy, does it go down faster versus if the object is light? So all of those, remember we said that young children are natural explorers. They naturally are curious. So they're going to do a lot of this on their own, just by you giving them the objects to explore, but you have to be there to label those actions, to use that vocabulary. But look at that round ball, roll down the ramp, roll down ramp. I wonder, you could ask the question like, I wonder, this was a round ball, but what would happen if we put a triangle? What other shapes could we put and see what happens when we place them at the top of the ramp? So putting those objects. Oh, incline, height, depth. Oh, what happened? It has wheels. So that's different from the ball, right? So making it, that concept of letting them explore these concepts. These are early, engineering concepts, right? That we're developing with, in this case, 2 and 3 to 5-year-olds. Then, because I always come back to language, remember to connect your math vocabulary with literacy and language development. So in the picture on the left, that's a feely box. You could call it a mystery box, but you put the shapes in there and the children feel it and they have to start talking about it. Like, do you feel corners? Do you feel sides? Do you feel edges? Is it, curved? Is it a straight line? So they start describing the attributes of the shape and trying to guess what it is. And they're using that vocabulary. And this, of course, is important to do with partners because they have to be able to interact with others to be using that vocabulary. The one on the right, then, the teacher was using just sentence stems. So they would pick up the shape and they would say like, I'm an octagon. I have, 8 corners. I have 3 faces. I have 3 sides, whatever, language she was using, but they have a sentence stem and the words are there for them to see. So even though they're not reading the words, right? What are they reading? The pictures, right? They're reading the picture like, oh, I am a circle. They see the picture, but I'm attaching this abstract concept of symbol with the letters to the object. So that's, again, going back to rich descriptive vocabulary that I'm going to attach to the object. Then here in this one, I got, these two I found on the internet because I didn't have pictures with me, but here again, they are scooping and sorting shapes, scooping and sorting. And then here they're using one-to-one correspondence where they are actually using little tweezers to fine motor skills to pick up the object and put it in the appropriate space as they're sorting. And sorting is definitely a precursor to more abstract patterning. So in the bucket, right, they could be shells, tiles, and rocks. And here's an opportunity for you to ask families, could you send these little things, objects that you have at home, right, in your junk drawer? Like I have tons of buttons that come with clothing as extra buttons, and asking families to send that with you so that they can start sorting. So center activities that they can engage in. I'm going to skip this one, but when we think about pattern blocks, we know that there are lots of concepts that children will develop. Oh, yeah, Lamont says dollar store. Yes, definitely. But we're trying to get the families to contribute too. So yes. So when we look at pattern blocks, then you think about what is, what language is being developed, what math language. It's again, thinking about using terms like vertices, angles. Are they the same size, right? Is it symmetrical? Is it equal? Is it narrow? Is it wider? Let's compose, put together, versus let's decompose, take apart, because later we're going to decompose through subtraction, right? So thinking flexibly and logically about the shapes, but using richer academic vocabulary. So that means I have to go find out what is that vocabulary, right? I have to think, and if I need to, I'm going to post the labels to remind me this is the vocabulary that I need to be using. Angles, vertices, narrow, wider. Let me try to get my slide to go. So pattern blocks, they're going to use the shapes, the sides, counting, the longer, the shorter, the corners, the vertices, the angles. This concept of if we turn this shape upside down, is it still the same shape? And then, of course, looking around the classroom or outside on a nature walk for other shapes that are similar. So really, we're thinking of giving children opportunities to mathematize. So here the picture is of shoes. So the question is, in your class, how do you mathematize with your children using shoes and socks? How do you mathematize using shoes and socks? Or how do you mathematize?
You could do by color. You could compare length of the shoes.
The types of shoes.
The type, like Velcro or tennis shoes versus the little like ballet shoe. We could measure them, like you said, Tamara, using standard objects or non-standard objects. We could, of course, count, we can sort. And then the jackets, we could look at shoes with laces, without laces. How about jackets?
Color, contents.
Yep. Zippers, no zipper, but zipper versus buttons. So we're sorting like these have zippers, these have buttons. And again, it's things that they're familiar with. So when they go home, what's interesting, right? Or the thickness, I like that, is that they'll say, Mom, my jacket has zippers, but your jacket has buttons. They'll start to notice it outside of school too. The size, like let's look inside the shoe. What size does it have? What number does it have, right? Create a graph to represent the comparison. Oh, does the jacket have a hood? Which jacket has a hood? Which one doesn't, right? Yeah. And I wanted to just share a study that I did in preschool where we asked children at the Math Center to go always to be with a partner, because to develop language, I have to hear language, but I have to use language. So when we asked them to go to the center, and in this case, they were working on patterns, we just kind of let them go. And of course, they would go to their center and they'd work with their partner. And we were observing what did they do at the Math Center. And what we found that they did was they would use they were showing what they knew in multiple ways, right? So they were trying out math ideas in these smaller groupings. So one way they did that was through drawings, right? So in this case, they're drawing patterns using shells. And this again is a good opportunity to have families send things from home. They use the actual concrete objects like the shells to create patterns and to sort. So they have beans, they have, things that they can sort. And they also explored patterns outside, explored patterns in the classroom. And they also the teacher was introducing patterning through music. So this whole time they were discussing patterns. So when they would come to the center, that's what they were practicing. But they also, what they did, and this is again, because they had a partner, they used physical movement to represent patterns. So here, one of the little girls said, oh, we could do these patterns with our legs and feet. This one is clap, stomp, stomp, clap. And then she says, it's 2 stomps and a clap, right? So the idea of the partner for us was the language that children were engaging in, but also the opportunities they had to show their peers their understanding of patterns. And in this example, it's the same classroom, same study. Diego is talking to Alicia and he says, Alicia, look. And he's doing a pattern. He says, diamond, circle, triangle. And then he catches himself and he says, no, diamond, circle, diamond, right? So the thing is, if he hadn't had an opportunity to talk with a partner and show her, look what I'm creating as pattern and saying it out loud, he wouldn't have caught himself, right? He wouldn't have made, oh, wait, that doesn't make sense. So it's also that ability that cognition of what I'm learning is being developed at the same time. So again, with math, we're looking at, easy concepts from number sense all the way to more complex with patterning. And I love these with just the clothespins because it's also part of that fine motor skills. And then we said earlier in Head Start, when they're setting the table, how many do we need? How many are there? How many children? How many plates? How do we figure out how many we need? And then you all talked about graphing. And what I liked is, of course, they were using their own, how many letters in your name? They were talking about their hair. Is your hair short, medium length, or long? So they're graphing it. And then, what I want to be when I grow up. And you can see how children are drawing their pictures there. So using their names, their own attributes of hair length, and then their ideas of what they want it to be. So you're combining language, in this case with social studies, with literacy, right, and with math. In science, I'm going to give you this riddle and see if you can figure this one out. It says, I can be hot, I can be cold, I can run, and I can be still. I can be hard, and I can be soft. What am I?
Metal?
Metal? Okay, that's a good guess. Let's see, I'm going to give you all time to, somebody said water. And the answer is water, right? I can run like a running stream. I can be cold. I can be soft. I can be hot. I can be cold. I can drip, right? It's another stages of water, right? Very good. So again, I'm going to shift us quickly because I've seen my time into science. And again, we talked earlier, the natural world is, children are fascinated by the natural world, right? They like to take these nature walks, observe the rain, throw items in puddles of water. So science is an easy one. We can go from, physical science, life science, to earth and space science. You all, I'm sure, are really good at, let's talk about the weather and what we see outside. Let's talk about plants and animals. And again, using that vocabulary of, like earlier we said, it's an incline, right? Using our vocabulary of, let's make an observation, let's make a prediction. And then, of course, those position words like under, over, inside. And so really using the language of science. So I'm going to skip through this one and we're going to look at so let's talk about this as a group. If I gave children these three objects, right? What science vocabulary could you use when they're exploring, you as a teacher, what vocabulary could you use when they're exploring these materials? So it's, clothespins, fingerprints, magnets. So let's think about the science concepts they could develop, some math concepts, and then, of course, the vocabulary. You can choose one and then think of that. Attract, repel, making connections, whether it's magnetic, does it attach, making a structure, the texture, the properties. So if we just, do the magnets push or pull? Do they attract, right? What objects do they attract? How could we find out is a question I could be asking them. How do you think these work? Why do you think they work this way? Why do you think our fingerprints look like this? Right? So just getting children to tell you what they're thinking is significant. And of course, seeing what they can design with those fingerprints and with the clothespins. So again, an easy science concept to be studying in your classroom is really investigating small animals, little creatures, creating this little gardening in your own classroom, this little container, and they can start thinking about collecting data and with objects, creatures that are in there that are living and non-living, talking about characteristics, life cycles. And then, of course, kids are fascinated. I showed you earlier the beetle. They're fascinated by bugs and insects that they see at home. And so insects is actually a great thematic topic to study because we have insects in everybody's culture. We find insects in everybody's home and everybody's backyard. And if you think about, what do they know about insects? And I have this picture of the corn with that worm, because when I was growing up, my mother would make me shuck the corn, right? I had to peel the corn to clean it. And invariably there'd be a worm in there and it would drive me crazy as a younger kid. So insects are a good activity for kids because they're culturally relevant. They are personally relevant, right? Because we have our own experiences, and I can connect it to books that we're reading. I can connect it to science, to math. And then the other thing for you to think about is using that rich descriptive language, using the name of the creature, like this is a arachnid, right? The spider is an arachnid, or that beetle is an insect, and trying not to use negative labels. And this is hard, right? When we're like, that's so gross. Oh, get away from me. Because of course we're trying to be scientists where we're excited about exploring our natural world.
This plaid wasn't available for men's, was it?
Not that specific chapter.
So when we think about learning about insects, you can ask children to take pictures of them at home and then bring them to school, and they can use the magnifying glass. You can actually bring the insects to school and they can draw and sketch them. And then they can draw and write about the insects that they are finding or that they have brought from home, or insects that you see outside when you take your nature walk. So, using those science concepts, but also thinking about the language and literacy. But what's happening, because they're seeing the real object, right, the real insect, we are continuing to decontextualize language because they're going to connect what they see, what they hear, what they smell, what they feel. If I put that beetle on my hand, I'll feel it, and they're connected to the vocabulary that you're sharing with them. And then we can write about it, you know, if we're studying insects. And here's all this vocabulary that we can be using with when we're studying insects. So we are asking teachers to let children experience with their senses, use that vocabulary, write it, and then read it. Like we can come back and read our anchor chart about what we've learned about insects. And look at all that vocabulary with what insects can do, right? They can crawl, they can sting, they can fly, they can creep, right? So all of that is vocabulary that I'm developing through my science. Yes, using little water bottles to catch and observe insects too. And also we've had to be very careful about, don't touch the insect, use a stick, right? A little twig and push it into the little water bottle or your little container so that you don't actually, we don't want anybody to get stung. And then, because this is, again, I got, you know, ideas from teachers is they then take all of those concepts of insects and they move it into their centers. So here are the words we're studying, and now they're spelling them. And then over here, oruga is caterpillar, and they're creating caterpillars with their Play-Doh right at the center. And then here, they're creating they moved it from the paper, here's the paper, to the plastic insect. So now they're recreating the plastic insect, and they're having to do the head, the thorax, the abdomen, the antenna, the segments on the legs, and then of course on the right one, they're just exploring insects in the soil. It was mulch, actually, mulch that they were in. So the science concepts, you know, we're in this case, being very thematic with how we're structuring it throughout my day to not just teach math or science concepts, but literacy concepts as well. Fine motor skills. And then I think just because of my time frame, I'm going to skip that little video. They were doing sink and float. So they actually tested out their objects with sink and float. And then they talked about what actually floated and what sank. And they wrote about it. These were the objects that, in this case, Diego brought objects from home. He brought a little toy dog, and that little toy dog floated. So they're writing their experiments, writing it out. Something else that I just saw 2 weeks ago was in preschool, they were studying about shadows. I had to think about it with English, shadows. And what would happen is when she got closer to the light versus when she got further away from the light. And then the children were allowed to have their own little flashlight and see what was happening with the shadows. So, of course, why do we have them with a partner? Because the interaction is part of the learning process. And then this was the vocabulary they were using, right? It was sunny outside. They had an object they were using, and so there was a shadow. So it was all vocabulary that was being developed for them with these science concepts. The other thing I want to remind you is using music. So Jose Luis Orozco is a very famous musician for children that does songs in English and in Spanish. And here, this CD here is, or song, CDs is what I use. I don't know what we use anymore. It's about healthy eating, but he also uses it for counting and for science concepts. And then Uno, Dos, Tres con Andrés is another that it's just 1, 2, 3 Andrés. And it's the same idea of they're using songs to develop science concepts. And it's just 123andres.com. And then this one is Mr. B. And he does science concepts, but he uses more of hip hop. So it's learning science concepts or math concepts through music. So it's Mr. B, 123 Andres, and then Jose Luis Orozco. And all of this you can find on YouTube and download it. So again, all of these activities that we're talking about is children are engaging in observations, comparisons, classifications, they're communicating, and the teacher, of course, is really setting this tone by the teacher herself or himself being excited, curious about these concepts, interacting with children throughout the day, you know, when they're playing, when they're lessons, and they're at centers, and using that math and science vocabulary, observing, right, informal observations to determine how children are learning, and so that I can individualize my instruction. And then here, I'm just going to give you this little example. So here they go outside, and it says, when you listen to children, you also want to follow children's leads. So it says, if you see that Luis picks up a snail and starts to study the bottom of the snail, don't answer too quickly, right? Let them look at it, think about it, and then start asking genuine questions. But plan the questions so that you're not just saying, oh, wow, that's an interesting snail, but really think about what parts of the snail what language could I use, right? So snails don't have antenna, they have tentacles. And that squishy part there that you think is the body is really called the foot. And then really, you know, looking at that and saying, why do you think this shell is in this, you know, shape that it makes with the whorl right there? So thinking about being very intentional with the vocabulary that you're going to be using. So I'm going to just give you this one. So if the children were building with blocks, the teacher says, what are you making? And Mael responds, it's a skyscraper. We have a tendency to say, oh, that's nice, you're building a skyscraper. And maybe saying, but be careful, it doesn't fall on you. But what would if I'm using rich descriptive vocabulary, what could I say instead?
How tall is it?
I wonder how tall it is. Let's measure it. And we could use, you know, again, standard or non-standard units. So I wonder how tall your skyscraper is. You could talk about whether it's symmetrical or not. Tell me how you built it. That's good. Language. Tell me how you built it. Oh, let's talk about the perimeter of your skyscraper. Or maybe you noticed that you put, oh, I see you put bigger blocks on the bottom. Why did you do that? Yeah, Lamont says, I wonder how that skyscraper looks to an ant. So now we're talking about perspectives, right? Point of view. Look how you're balancing, right? How many blocks did you use? And why did you put the big blocks on the bottom? So asking them to explain it to you, right? So here are some questions just in general. Now remember, you will be getting the handout, but just questions that you could be asking children, right? Even if you don't know the answer, I don't know, but what could we do to find out, right? So helping them learn how to research it. I wonder what that beetle might like to eat, right? I wonder if that beetle is crunchy. So you will be getting this. So again, just to summarize for us, what is and I'm going to ask you this question, what is the role of the teacher during math and science? If I'm thinking of developing math and science, what is the role of the teacher? I don't know if now you can hear my little dogs out here.
Facilitate learning.
Okay, we're facilitating, but we're going to be really intentional because we're going to do what? Look at my chat. Give them the vocabulary. So I'm going to facilitate the learning, but I'm going to provide the vocabulary, rich language. I'm going to be repetitive. I'm going to actually have to learn some of this vocabulary myself, right? I'm going to use the language of math and science daily. So this becomes just a habit of mind, using these questions to promote thinking, right? Like, I wonder why that happens. Let's, what do you think is happening? Why do you think that happens? And just really remembering that young children are naturally scientists. They are just naturally born scientists. They are curious. They want to explore. They want to observe. And we really have to provide that proper environment as facilitators, provide those experiences that are sensory-based, hands-on and concrete, and then guiding those discoveries for young children. Ask open-ended questions, give them time to respond, and let them think it through. Very good, Patricia, yes. So it is 5:31. Thank you so much. Here's my email. If you think of a question or you have something you want to share with me, email it, even if it's like, I look at something I did with my kids that I want to share with you. That would be fantastic to share with me. And Patricia, you're asking about in Spanish. Well, we will have 2 other sessions in Spanish, but I will tell you the topic will be it won't necessarily be math and science. It'll be a little different, but they do have 2, one in April and one in May. So again, I thank you so much for your attention. I know, like I said earlier, it's a long day for you. I'm sure you got started very early, and I appreciate your attention throughout the session. Like Susie said, there will be an email that will go out with the handout, and it will also have the evaluation. And of course, we appreciate you filling that out. And then Susie reminds you to visit the ECPL website to register for those other professional learning opportunities. If you have questions, I'll be here. If you are ready to go, I'll say good night, buenas noches, sayonara, hasta luego. Enjoy the rest of your evening. But like I said, I'm here if you have a question.
Thank you so much, Dr. Alniz. And thanks to everybody for joining us today. Again, the sessions that will be sponsored by the Stone Foundation are going to be presented in Spanish. That is on March 12th, developing interactive read alouds to enhance literacy for young dual language learners. And then the one on April 11th is creating language opportunities during play-based learning. And both of those will be presented by Dr. Salinas Gonzalez. And there is still room for registration. So we would invite you to go on to our website and register for those.